This video covers review 15 over exponential functions. So part 1, the number of stores opened by a retail clothing company can be modeled by the exponential function graphed on the grid, where x is the number of years since 2000. Based on the graph, which equation or which statement does not appear to be true? So the retail clothing company had opened 12 stores by the end of 2002. So remember, this is number of years since 2002, so 0 years have passed, and that does look about 12. They've asked us which is not true, so that's not going to be it. Every year, the number of retail clothing company opened increased by 25%. That looks to be true. Let's say if we thought this was 12, then this is 15, that's 20, 25, 30. 35. Yeah, this is pretty close to a fourth. If you're not sure, skip it. See if there's one that's really obviously not right. Part C says since 2000, the retail clothing company has opened between 3 to 5 stores each year. Well, let's see. That seems to be true, but let's double check. So if we said this is 12 and 15 and these are increasing by 5s for a little bit, then that's pretty accurate. Well, let's see if we go over here. So like year 6, they opened, let's say, 45. And then year 7, they're up to almost 60. Well, that's a 15 store difference, which is not between 3 to 5 stores. So that one's obviously wrong. And then part D, they opened 3 stores in 1 year. Well, yeah, that's true. So from year 0 to 1, they did that. So that's where if you're not sure about something like answer choice B, go see if one of them is obviously wrong. Part 2, they tell me the table of values is for an exponential function shown below. So we know it's exponential. Which situation could describe this function? So first thing I'm going to do is look at the table. 265, 276. These numbers are increasing. So anything that says decreases, I'm going to mark out. So now I got 2 answer choices left. Percentages are exponential functions, and whole numbers are linear. So let me see. This, said it was an exponential function, so that has to be answer choice C. Can't be D because D is a linear function, but they told you it was exponential. Part 3, identify domain and range. So remember, my domain is my x's. We always go least to greatest. So my lowest x is -1. It goes all the way out to a +3, and both of those would be included. My y's go from about 6 up to 27. So remember, you just box and you look at your x's left to right, y's bottom to top. Problem 4, Martin opened a money market account. Martin's investment account balance to the nearest dollar can be determined using the exponential function 1000 times 1.06 raised to the x, where x represents the number of years the money is left to grow untouched. Which of the following best represents the meaning of the value 1.06 in the function? So that 1.06 is my growth. I know it's a growth because it's bigger than 1. Okay. Remember, it's initial and then where it's going. So where does it start and where does it go? So this one is growing. So anything that doesn't say growth or a percent of growth or a rate of growth, I'm going to mark out. So rate of growth, that's true. Number of years needed, nope, that's not growing. Initial deposit, that's part A. That's not the part we're talking about. And then the number of times, well, we can't predict that. So it's got to be answer choice A. Problem 5, we're studying a bacteria sample. The function f of x equals 245 times 1.12 to the x gives the number of bacteria sample in the end of x days. Which statement is the best interpretation of one of the values in this function? So the initial number of bacteria is 12. So is my starting number 12? No, my initial number is 245, so that's not right. The initial number decreases. Is this decreasing? No. This is increasing. I know it's increasing because it's bigger than 1. Number of bacteria increases, true, at a rate of 12% a day. That looks good. Bacteria at the end of one day is 245. No, 245 is the start of one day, not the end of one day. So that would be answer choice H. Problem 6, we have 4 viruses that have growth rates that can be expressed using this parent function. 4 radioactive isotopes have decay rates that can be expressed using the parent function. Which of them will decay at the fastest rate? So the fastest decay is going to be the smallest fraction. So the smallest fraction I see is 1/4. These are all not the smallest. Now keep in mind, growth is the biggest number. So if you see this question but with growth instead of decay, you're looking for the biggest number. Problem 7, the rate at which cell phone subscribers increased per year after 1985 in a given city is modeled by the exponential function 285 times 1.75 raised to the x. James was asked to tell the meaning of the value of the numbers in the function rule. Which of the following would be the best answer? So f, the value 285 represents the initial number. That's true. It represents a start. And 1.75 is the rate of increase on new subscribers. That seems pretty good. We're talking about increasing and initial starting. 285 is current subscribers. Well, no, that's not. It's how many they started with, not current. Same thing on H. It's how many they started with. 285 is the population of the city. Well, no, we're talking about cell phone subscribers, and we're not talking about people that move in. We're talking about cell phones. So I'm just looking for keywords on that. I didn't even read everything. Part 8, Ms. Hawkins took 300 milligrams of migraine medication before school started. The drug has a half-life of 1 day. Write an equation to represent the amount of the drug left in her system as a function of the number of days that have passed. So we're going to write a function about Ms. Hawkins' today's. She started with 300 milligrams. There is a half-life, so it cuts in half, and then raised to the number of days that have passed. Problem 9, Sarah's investing graduation money. She has $1,750 that pays an interest rate of 6% annually. So this is how much she starts with. All of these answer choices have that starting. Now keep in mind, Jay, we've never seen something that looked like that. So let's go ahead and mark that out. And then it's growing. So we have 1 plus her rate as a decimal, to the left, to the left. So 1.06, well, that's not growing and that's not growing. G is the only one that shows a growth for the equation. So problem 10, we're doing something similar. Total metric tons of copper produced in the world was this, so that's how much we're starting with. Each year since, the number of copper produced has decreased by half of the previous year. So which one shows the number of tons of copper produced in the year since? So we're starting with 495,000. All of these do that. Keep in mind again, C and D, we haven't seen anything like that. So we're going to cross those out because that doesn't look like anything we've studied. Then I'm looking at A and B. One of them is growing, one of them is decaying. Well, if this was decreased, it can't be getting bigger. It would have to be getting smaller. So decreased by half is 50%. As a decimal, that is 0.50. Problem 11, we're talking a problem about guinea pigs. So we have the exponential function below. They give us a table and a graph, and they ask us, based on this, which one is the closest to the guinea pigs after 18 months. So I'm going to go to Stat Edit and run a regression. I'm going to plug my table in like I see it. And then I'm going to do stat, scroll to calc, option 0 is xreg. So my equation is 23, or we could say 24. But for that rate, I need to get like 3 numbers after the decimal. Okay. So my 18 months is going to be plugged in for x, so I can either type it in or I can store that equation into y equals or retype my rounded one, whatever you want to do. But I get about 730, which is pretty close to answer choice G. Now, if you did this one and you didn't get the right answer, it could be that you rounded too early. When I rounded too early and did 1.2 when I was first working it out, I got about 630, which is kind of in between F and G. So if you don't get a number, then keep rounding, or don't round as much. Domain of an exponential function is always all reals. Remember, you could see it either way on the test. Both of these show up, but this one actually shows up the most. Determine the domain and range of the following. Domain is always all reals. And then for the range, I could plug this into y equals to see what it's doing. So a is 1/3, and then b is 4 raised to the x. So I am plugging in a and b with 1/3 and 4. I'm going to look at my graph, and this graph looks like it's getting pretty close to 0, so my range is greater than 0. They want me to draw a graph that represents growth and another one that represents decay. So growth is going up from left to right. Decay is going down from left to right. So they just want a sample picture. So if you need a pause to draw those, that's fine. 15, we're talking rabbits based on this table, which function represents the same relationship. So first, I notice that I have my a value of 5, so I'm going to mark out anything that's not 5. But then again, C and D, we haven't seen anything like that, so it must be answer choice A. If you didn't want to do that, you have two options. First, you could plug these into y equals, see which table matches, or you could put this in stat edit and see what equation you get out of it. These are the start of our review problems. 16, we have a 0.37. They want a line that is parallel to the axis that goes through that point. So the x-axis is this one. Parallel means the same. This equation is a Hoy equation. So my equation is going to be y equals 7, and my slope of a Hoy is 0. So that's just a special case. 17, rate of change. I'm going to solve for y. Divide by -6, so I get 1/2 x minus 5. My rate of change is whatever number is in front of x, so that would be 1/2. The 0 for 4x minus 8, I can plug this into y equals and see where it crosses the x-axis, because x-intercept is the same thing as 0. This crosses at a positive 2. 19, they want an expression equivalent to this. So remember, cubed gets distributed. C to the 5 cubed. These are multiplied, and these are multiplied. So 8 cubed is 512. C to the 5 times 3 is 15. 8 times 1/2 is 4. So 15 plus 4 is 19. So those are just your exponent rules there. 20, they give us this function that can be used to determine the cost in dollars for a taxi ride of X miles. What is the rate of change of the cost in dollars with respect to miles? Rate of change means the same thing as slope. Slope is always found in front of X, so 275 times X would be my slope. If you wanted, you could do a couple things with that, like simplify your equation. It's just not really necessary because you can see the slope really quickly. And then 21, which of these best represents this equation? So first thing I can do is plug it into y equals, so 2 raised to the x. Look at my graph, see if anything is blatantly obvious. B and C are blatantly not matching that, but A and D look really close. So I'm going to write down some points from my table and check some points to match. So 0, 1, 1, 2, 2, 4, 3, 8. So if I look at A is 0, 1, 1, 2, 2, 4, 3, 8, all of those seem to hit. If I look at D, 0, 1 looks a little off. 1, 2, 2, 4, 3, 8. So I got 2 points here and here that don't look quite right. So A is going to be my final answer on that.